Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list from our SD sheet. So let me show you the problem that we are going to discuss today. Okay, so this is rotating your linked list. Rotate a linked list. Okay, so let's have a look how can we solve this problem. Let me check if we are live. Yes, we are. Okay. So you are given a linked list like this and you are given an integer k, which tells you that you have to left shift the linked list by k nodes. What do you mean by left shift? That means you have to rotate your linked list in such a way that the first two k nodes are shifted from front and they are moved to back one by one. Now this is simply rotation of the nodes from front to the back side, to the rear side of this linked list. Now let's understand how we can do. As you can see here in the first rotation, when I talk about first rotation, left shift means we are moving the head node from its current position to the tail side, right? So your linked list becomes 4, 7, 8, 9 and 2, as you can see here. Now you are left with 4, so you have to do this thing 3 times. So this is your subsequent list after one rotation. Then on second rotation you will move this 4 from here to here, you get this. Now on third rotation you move this 7, so this is the final linked list. Now what you will have to return, the new head is this 8, so this is what you need to return to your linked list, the new head after doing rotation by k times in such a way that you are left shifting the linked list by k nodes. Let's just see how we are going to do this thing. So for example, you have a linked list like this. For example, I have a linked list 10, 20, okay, just a second, 30, 40, 50, okay, and I ask you to rotate this linked list, left shift this linked list by k equal to 4 times. So what are you going to do? Your k is equal to 4 I am giving you. How are you going to do this question? So it's very simple. K equal to 4. What you have to do is basically when you are first time doing this rotation, you have to break this link from here and form a link towards the end of your linked list. So this is how it is going to look like after doing first rotation, right? This is about your first rotation. So this has been removed from here. Your new head comes at 20. Now this was about rotating it once. Now this is your linked list right now from here till here. New head is this 20. You have to do it 4 times. So on second time, this 20's link to 30 will be broken and the 20 will come right after 10. So this is how it is going to look like. Move it and it becomes 10 is connecting to 20. It is pointing to 20, right? This is rotation number 2. On third rotation, this is your new head. Now your linked list is 30, 40, 50, 60, 10 and 20. On third rotation, your 30 should break its link from here and move right next to the last node, that is 20, and it becomes 30. So your new head points to 40. What is your newly formed linked list now? Now you see linked list looks like this, where your new head is 40. So the address of this node has to be written. That is what is the demand of this question. Got it? If it was for 3 times, and one thing they have already given you to make it a little bit easier, k is always going to be less than or equal to the length of your linked list. How it is helping us? Actually it is saving us some time and efforts to find the length of the linked list and check if k lies within that length or if it exceeds the length of the linked list. If that is the case, then I will have to use k equal to k remainder length, so that, see, I'm just adding up this point so that in future when it comes you are not confused what I'm trying to say. And this question does not ask you to do these stuffs, but I'll tell you what. For example, the length of your linked list is 4, okay. If your k is equal to 4, when your k is equal to 4, you have completed one entire loop of rotating this linked list, and you will come back at this position only, because one rotation will bring 10 here, second rotation will bring 20 here, third rotation will bring 30 there, and fourth rotation will bring 40 there. So fine, again you are going to get 10, 20, 30, 40. So that means when k becomes equal to the size of your linked list and these many rotations and the multiples of this length is always going to give you the exact same linked list. Now if for example k was equal to 5, so ideally when k was equal to 4 you came back to the original form of the linked list. So when k is equal to 5, that will clearly means one rotation. You got it? When I say k equal to 6, so you can judge it from here that when k was equal to 4 you were getting the original linked list. So when k is equal to 6, that means you are doing two rotations. So how will you judge that, or how will you know that it is equal to two rotations when k equal to 6? It is nothing but it is k remainder the actual length of your linked list. The length of linked list was 4, so 6 remainder 4 is what? 2. That is actually giving you the number of times you have to actually rotate your linked list of rotation, you can say, right? So just that thing will be saved here, that effort will be saved here, because the question already tells you that k will never exceed the length of your linked list C. Your task is to left shift where k is a given positive integer smaller than or equal to the length of the linked list. Okay. Okay, so the thing that we discussed here is exactly what we are going to do in the code. It's nothing, it's simply breaking the link of head to its head next. Okay, means basically I want this head. Let me start up with a pseudocode so that you can understand it better. Now for example, you have 10, 20, 30, 40 and 50. Let's say I'm rotating it 3 times. Okay, so what is going to happen? Let's say I am taking two nodes here, node temp pointing to head, okay, and node tail also initially pointing to head, but my aim is to bring tail to the last node of every state of a linked list. Right now my temp is here and my tail is here. So first of all, my target is to bring tail to the last node of this linked list. So by one loop, that will be while your tail dot next is not equal to null, make tail equal to tail dot next. So that will bring your tail here pointing to this node. Now what I have to do is I want to break this link. I want to break this link and form a new link to the tails next, right? So this tail dot next should be pointing to temp. So for that case, now this is when you are doing your rotation once, and I have to do this thing 3 times. So I can take a while loop which is running until your k becomes equal to 0. So while k is not equal to 0, what I'm doing is, see, first of all I am bringing your tail becomes here. That thing I'll do previously only before this while loop. Now your tail is this. Okay, temp is already pointing to head. First thing that I want to do is I want to store the address of this node. Okay, so you know this is temp, but by default head is also this. So so that I can have the address of the next head after one rotation, I am making my head point to this node. So let's do one thing, head equal to head dot next, so that when I lose this link, I still have the address of this link. So right now your head is pointing here. Now your next target is to form a link after tail, that is tail is pointing to your 10. This is for your first rotation. So now the next thing is your tail dot next. Before I do this, let's do one thing. I have to break the link. To break this link, let's do one thing, make your temp point to null, temp dot next equal to null, right? So this bond has been broken and your 10 is pointing to null right now. Now I want this entire thing to move from here, sorry, I want this entire thing to move let it be, to move from here to here, right? It should become something like this, right? So this entire 10 pointing to null should come after this tail. So tail dot next should be pointing to temp. So this will create this link, correct? This link has been created now. Now what is your linked list looking like? right now your temp is still pointing to 10. Your temp is still pointing to 10. This node has been removed. Your head is pointing to 20. Now let's do one thing. What do we want to do is, now I have to do this until my, for 3 times. I have to do this 3 times because k equal to 3. So this is when I have done one rotation. Now for the next rotation also, I want everything in the same way so that I can get tail node is pointing to the last node. So make your tail point to the last node. So tail should become tail equal to tail dot next, so that I can get the same thing when I am doing the next iteration. Okay. Next thing is your head is here, that is fine, but you remember that temp is still pointing to 10, and I actually want my temp pointing to head so that I can redo the things that I did for first rotation. You got it? So also do one more thing, that temp should be pointing to your head, and your head right now is pointing to 20. So this temp node is no longer pointing to 10, and this 10 is now this 10 is can be accessed by tail node, because your tail is pointing to 10 right now, right? This is, and do k minus minus. I am starting when, because my k for example is 3, so this is when I did one rotation. Now k minus minus, that is for second rotation. So eventually when k becomes equal to 0, you will be having the new rotated linked list. Now let's try one more time. Okay, so your head is pointing to head dot next. Now your head is removed from here. I move your head from here to here so that I can have the address of it. Okay, next is temp dot next equal to null. I am breaking this bond and making it null, and this bond has been, this link has been removed. Next step, your tail dot next is pointing to temp. So your tail dot next is pointing to temp. Temp is 20. So 10 is actually pointing to what? 20. And 20 by default is pointing to, not by default, this is what we did. Okay, and temp is still at 20. Got it? So the next step is this, tail becomes equal to tail dot next, or you can say instead of tail dot next, make your tail point to temp. That would be a better thing to do, so that you can, tail is actually pointing to temp node. So tail from here comes here. This is where your tail is present now. Cool. And your temp is pointing to head. So your temp gets removed from here. Your temp node is your, this, all of these things get removed, and your temp is pointing to 30 now, so that I can repeat the same process. So k was initially 3. This step, for this step k was 2, and you are doing k minus minus, so your k becomes equal to 1 now. For the next iteration, I have to do this thing 3 times. Twice I have done. This is your, when your k equal to 1, do the same thing. Now again after this thing, you will see that 20 will be pointing to 30, and 30 will be removed from here. This bond is no longer existing. Head will be pointing to 40 now. Okay, head will be pointing to 40, temp will be pointing to 40, tail will be pointing to 30, and this is pointing to null. And what, now your k becomes equal to 0 when you reach at this step of k minus minus. So when your k is equal to 0, you'll come out of this loop and you see where your head is pointing to. Isn't this what we wanted? Yes, this is exactly the rotated linked list. Okay, so I hope this thing is clear to you. We are doing this thing in maximum on of time complexity, and also when your k becomes equal to n in that case. Otherwise you see that we are, how much we are actually moving 3 nodes. When we wanted to rotate it by 3 times, we were actually moving 3 nodes, and that's what we are exactly doing. Okay, so also what next, I think, yeah, that's all about this problem. So let's try and code it. I'll just check if you guys are able to. Thank you, Ashish. This motivates me to be better every time with the new lecture. So let's move to the code part now. I'll just start coding it. See, now if you have understood the question how I discussed just now, the code is going to become very easy for you, because I have already pseudo coded what we are actually going to code. Okay, so let's start off. What are we going to do? I am taking 2 nodes, node temp equal to head. Okay, then I have node tail, as I told you, I am taking tail pointing to head. Okay, and one condition I am taking, if head itself is a null, okay, null pointer, and k is equal to 0, that means no rotations are required, right? So why go into that while loop? Just return it from here if head is equal to null or your k is equal to 0. In that case, return your head right away. Fine. Now let's do one thing before we move to the while loop that I just discussed. Let me bring my tail to the last node, right? Because I will proceed in my while loop. So while my tail dot next is not equal to null, I am bringing my tail to the last node of my linked list. Tail equal to tail dot next. Now start off with your loop that I just discussed in the pseudocode while k is not equal to 0. Fine. What other things you are doing? You are breaking the bond, creating the bond, and keeping the address of the next head that you are going to get after that rotation. So first thing, your head is pointing to head dot next. Okay, because your temp is already present at your current head. Okay, head is now, I have made my head move to the next pointer, that is at 4. Okay, now what next thing, temp dot next, I am breaking that link from first node, that is from 2 to 4. This link I want to break, so temp dot next is pointing to null, and tail is already pointing at 9, so that I can have the address of the last node after which I want to add a new link. So tail dot next will be pointing to temp. Okay, once I have done this, let's relocate our nodes so that we can do the similar thing for the next rotations as well. So the next thing will be that your tail is pointing to temp is pointing to head, so that I can repeat the process and do k minus minus. Got it? Okay, and this thing continues until your k becomes equal to 0. Finally you return head. Let's check. Are we able to? Just a sec. Yep. And that's all about this problem. So not in fact, this is an easy problem only. I wouldn't say even medium as well. Just if you are clear with how to form the bonds, break the bonds, what actions you need to take, then this problem is very easy. Okay, so if you have any doubts, you can ask me in the chat. If there are no doubts, I will wrap this lecture. And okay guys, if there are no doubts, let's wrap it up. Fine, then see you all in the next lecture. Thank you everyone. Bye bye, take care.